Welcome to Study Loop.
Our question wants us to use figure 34-34 to figure out the distance below the mirror the surface of the image is of the bulb. So to do that, we went ahead and drew this free body diagram over here to the right, which shows several different triangles, like triangle OAB, triangle CBD, triangle AN, NDI, ANI. So we have these different triangles, and we can use the properties of these triangles to solve our question. So the first thing we're going to do is look at that free body diagram, and we're going to look at triangle OAB. So the tangent of the angle theta, and let's block off what we were given here, those two distances. So from triangle OAB, the tangent of the angle theta is equal to the distance from A to B divided by the distance D1. But we're going to use small angle approximations where the tangent of theta is approximately theta. So therefore, the distance AB is approximately equal to D1 times theta. So next, we're going to use triangle CBD from that image. And we see, we'll start a new page here so we don't run out of room. We see that the tangent of the new angle, theta prime, from triangle CBD is equal to the distance from B to C divided by 2 times the distance D2. And since tangent theta prime is approximately theta prime for small angle approximations, we get that the distance from B to C is approximately equal to 2 times the distance D2 times theta prime. And now we can apply Snell's law, which says that the ratio of the sine of the angle theta divided by the sine of the angle theta prime, which, since we're using small angle approximations, is the same as theta over theta prime. According to Snell's law, this is equal to the index of refraction of water, N sub W, divided by the index of refraction of air, N sub A. So we can solve this for theta prime, and we see that theta prime is equal to theta divided by N sub W, which is 1.33, times N sub A, which is 1, so it's just theta over 1.33. So therefore, we can go back to B sub C, or excuse me, the distance between B and C, and we see that B and C is approximately equal to 2 times D2. And then we're going to replace theta prime with theta divided by 1.33. So now we're going to use the triangle diagram, the triangle in the diagram that's equivalent with ACI. So ACI over there in that diagram. And we see that from that, we have, let's start a new page here. We have the distance between AI is equal to the distance between AN plus NI. And we can rearrange this to solve for NI because our question says how far below the mirror surface is the image of the bulb, and that is that distance NI. So we can rearrange this to solve for NI, and now it will become apparent why we did all the other pre-calculations. So NI is equal to AI minus AN. So let's first focus on AI. So just from trigonometry, the distance between AI is equal to the distance between AC divided by tangent of theta. And now we can use some of our approximations. We know that tangent of theta is approximately theta. So this is over theta. And we know that the distance between AC is equal to AB plus BC. But wait a second, we know AB and we know BC. We know BC is 2 times D2 multiplied by theta divided by 1.33. and AB is D1 times theta. So we can just go ahead and plug in those values, and we find a new expression for AI. We see that it's equal to D1 times theta plus 2 times D2 times theta over 1.33. And this is all divided by theta. And so now it makes sense why we put everything in terms of theta, because these theta values are going to cancel. That cancels with that, which cancels with that. And we're left with everything in terms of D1 and D2, which we know those values. So we can go back to solving for the distance between Ni. And we can replace a sub I with this new expression. So we have D1 plus 2D2 divided by 1.33 minus the distance between A and N. But the distance between A and N is just D2. So this is minus D2. So we know all the values in this expression. We can just simply plug them in, and we find that this is equal to 351 centimeters. We can box this in as the solution to our question.